Okay, so in this lecture video, we are talking about antiderivatives still, and we are going to be doing some more applications with antiderivatives. Okay, so let's look at that first story. It says a concert promoter sells tickets and has a marginal profit function given by P prime of X, where P prime of X is not only the marginal profit, but it's in dollars per ticket. This means that the rate of change, right? Marginal is speaking about the rate of change. We spoke about that in a previous lecture video, so remember that. This means that the rate of change of total profit with respect to the number of tickets sold, X, is the derivative function. And they want us to find the actual total profit from the sale of the first 60 tickets. And they said disregard any fixed costs. Okay, so here's the thing. Some reminders for us. When they give us the derivative, that is the rate of change. Marginal means the rate of change. In this case, the rate of change of the profit. And the profit's in dollars per tickets. They're asking us to find the actual cost. Not cost. They're actually asking us to find the total profit. Well, if P prime is the rate of change of the profit, the marginal profit, then how do I find the actual total profit? Yeah, I have to take the antiderivative. So, to find the actual profit, I'm going to take the antiderivative of the rate of change of the profit. So 9x minus the 1026 with respect to x. Okay, so I'm expecting you're very good with taking the antiderivatives of functions like this. Let's see if you follow along. So, and since it's a subtraction sign, I can look at them individually. So the first one is going to look like 9 times 1/2 x squared minus 1026x plus c. Always got to get that c in there, right? Okay, so our profit function is looking like 9/2 x squared minus 1026x plus c. And they would like us to find the sale of the first 60 tickets. But after that, do you notice it said disregard any fixed costs? So in a previous lecture, we had a business that had a $6,000 fixed cost, which means even if the business didn't open, they still had $6,000 worth of bills to pay every month. Utilities, mortgage, insurance, etc. Even if the business never opened their doors, they've got all that to pay. Well, in this case, they said disregard any fixed cost, which means this. If we're disregarding fixed costs, then when we sell 0 units, the profit at 0 is going to be 0. That's what it means by disregard any fixed costs. When we sell 0 tickets in this case, we're going to have $0. There won't be any profit whatsoever. That makes sense, right? So when we set this up, P of 0 is going to be 0 equals the 9/2. Now instead of x squared, you're going to have 0 squared minus 1026 times the 0 plus that c. And then when you simplify all this, you get that your c is equal to 0. All right. Well, that makes sense, yes? Okay. Which means the profit function we are actually working with is 9/2 x squared plus 1026 x, because the c is now 0. And they're asking us to find the sale of the first 60 tickets. So that means the number of tickets sold, right? That means we've got 60 tickets sold. So that's our x, isn't it? So the profit of 60 tickets means you're plugging it into the function, so 9/2 times 60 squared plus the 1026 times the 60. Okay, go ahead, get your calculators out. Let's see if we agree. My little cheat sheet says, yeah. You're like, wait, did I get the right number? If you got the same number I did, you got the right number. I got negative 45,360. Like, wait, that doesn't make sense. Actually, it does. In this case, your profit is a negative $45,000, pardon me, $45,360, a negative $45,360. What does that mean? If your profit's negative, what does that mean? Yeah, it means your cost is actually higher than the profit. If we sell 60 tickets, we ain't making a profit. We're in the hole $45,000. Yeah, that's not good. We need to sell a few more tickets, don't we? Okay, that makes sense? Lovely. Got another one. All right, the next problem, talking about coffee, isn't it? By the way, did you have your cup today? Or maybe you're a teetotaler. Either way, a coffee company has found that the marginal cost in dollars per pound of the coffee it roasts is represented by the function below. Here's that function, where X is the number of pounds of coffee roasted. They would like us to find the total cost of 120 pounds of coffee. Disregard any fixed costs. Okay, so as soon as they said marginal cost, we should have known that they were going to give us a function that was representing the derivative. Great. Well, they did. They gave us a function representing the derivative. That's the marginal cost. That's the rate of change with respect to the cost. Got it? Okay. So they have given us the rate of change of the cost, but they want us to find the actual cost. So what are we going to have to do? Yeah, we're going to have to take the antiderivative. Excellent. So to find the actual cost, we've got to take the antiderivative of this function, negative 0.012x plus 3.25 with respect to x. Agreed? Okay. So again, I'm hoping you're getting very good at taking the antiderivative. See if you follow along. So when I start taking the antiderivative, I get this negative 0.012 times 1/2 x squared plus 3.25x plus that c. Agreed? Simplifying it, I get the cost function as negative 0.006 x squared plus 3.25x plus c. Are we good so far? Awesome. Now, you know, they did say disregard any fixed costs, didn't they? So remember what that meant from the last problem? Yeah, so if I'm disregarding fixed costs, that means that the cost of 0 pounds of coffee is going to be 0. The cost of 0 pounds of coffee is going to be 0. We're disregarding the overhead that needs to be paid and insurance and utilities, all that stuff. We're disregarding that. Which means when I plug in that 0, I end up with 0 equals negative 0.006 times 0 squared plus 3.25 times 0 plus c, which means our c is actually equal to 0, isn't it? Yeah. Okay. So what does that mean in terms of our c of x? What's our c of x function? Our c of x function is going to be negative 0.006 x squared plus 3.25x. Good? All right. And they want us now to find the total cost of roasting 120 pounds of coffee. So what are we going to use? Are we going to use the C prime or are we going to use the C function? The C function. The C function represents the cost. What does the C prime represent? It represents the change of the cost, the marginal cost, the change. I'm not looking for the change. I'm looking for the actual cost. And they're telling us that we're roasting 120 pounds of coffee. Yep. Now, we got to be careful because they gave us a restriction that X has to be less than or equal to 100. Is the number of pounds of coffee less than or equal to 200? Yeah, it is, which means I can plug it in. So C of 120 equals negative 0.006 times 120 squared plus 3.25 times 120. And I know you have your calculators out already. So what did you get for the cost of 120 pounds of coffee? By the way, they shouldn't tell you where to round. Yeah, they want you to round to the nearest cent. So what do you get? Okay, I think we got the same thing. I got $303.60. That's what the cost is going to be to roast 120 pounds of coffee, disregarding any of the fixed costs. Good? Love it. Got another one. Ready for the next one? Okay. We have a note card company, and it's found that the marginal cost per card, okay, sounding familiar? Yeah, marginal cost is another way of saying the rate of change, isn't it? The rate of change of the cost. So, the marginal cost per card of producing X number of note cards is given by the function, negative 0.06x plus 76. And we've got a restriction. X is less than or equal to 1,000, right? All right. They ask us to find the total cost of producing 730 cards. Again, disregard any fixed costs. Fine, no problem. So, what do you think you're going to have to do? Yeah, you're going to have to take the antiderivative to find the actual cost. All right, so I take the antiderivative of the marginal cost, which is negative 0.06x plus 76 dx. Follow along. We have the negative 0.06 times 1/2 x squared plus 76x plus that c. Good, you always have to have that c in there. So that means our cost function is looking like negative 0.03x squared plus 76x. Good. Loving it. Nicely done. Getting the hang of taking the antiderivative? Good. And then what did it tell us? Yeah, they want us to find the total cost of producing 730 cards, but what did they say? Disregard any fixed costs. Okay, fine. So if I'm disregarding fixed costs, that means, yeah, that the cost, C, of producing 0 cards is going to be 0, isn't it? We're not taking into account utilities or mortgage or anything. We're disregarding all that stuff. Fine. Which means to actually find C, we're going to have 0 equaling negative 0.03 times 0 squared plus 76 times 0 plus the C. And by now you're like, okay, this is looking familiar. Of course it's looking familiar. That means C is equal to 0. Right? Which means your actual cost function with respect to X is negative 0.03x squared plus 76x. Yes? All right. And they would like us to find the total cost of producing 730 cards, which means your X is 730. Good. Gratefully, that's less than 1,000 because the restriction was that the number of note cards had to be less than 1,000. And if I'm looking for the cost, am I going to use the C of x function, or am I going to use the C prime of x? Use the C of x, because C of x is the actual cost. The C prime is the change in the cost, the rate of change of the cost. That's not what they're wanting. They want the physical cost. So, good. Negative 0.03 times 730 squared plus 76 times 730. Okay, what do your calculators give you when you do all your finger punching? And yes, they want you to round to the nearest cent. I ended up with 39,493 cents is what I ended up with. Because this marginal cost was in cents per card. So this is 39,493 cents. They did not ask you to put it in dollars, but if they asked you to put it in dollars, I hope you know how to put it in dollars. Good? All right. Got another one. Surprise, surprise. All right, next problem, talking about what? Talking about the marginal cost in dollars per addressed. Okay, so we've got a marginal cost problem again, and we're talking about dollars per address, right? The change, the rate of change in the cost per address. Okay, it's given by the function negative 6/25 x plus 60. They gave us a restriction, x has to be less than or equal to 450. Got it. X represents the number of addresses. C prime of x is the marginal cost. We've already decided that or discussed that. And they want us to find the total cost of producing the first 220 addresses. And again, disregard fixed costs. No problem. When we disregard fixed costs, it makes the problem a whole lot easier to deal with initially. Cool? Okay, so what are we going to have to do? Yep, you got it. Go find the antiderivative so I can find the actual cost. Wonderful. So antiderivative negative 6/25 x plus 60 dx. That means with respect to x, right? Okay, you do your work, I'll do my work. Hopefully the two of us will get the same thing. That will be lovely if we do. I've got negative 6/25 times the parentheses 1/2 x squared plus 60x plus that c. And I know some of you are thinking, do I have to put, yes, you have to put the c. Why? Because it's the habit you need to be in. Because sometimes they don't say disregard the fixed costs, and so you're going to actually have to find that c. But this problem says disregard, but still put the c in. Okay, so that means right now my cost function is looking like negative 3/25 x squared plus 60x plus c. And if some of you are wondering, how do you get negative 3/25? They're fractions. You're multiplying two fractions. Reduce. The 6 and the 2 reduce. The 2 becomes a 1, the 6 becomes a 3, right? Okay, so disregard fixed costs, which means the cost of producing 0 dresses is going to be 0, which means we end up with 0 equals negative 3/25 times 0 squared plus 60 times 0 plus c. Yep, you got it. C equals 0. No surprise. So that means your actual cost function is going to be negative 3/25 x squared plus 60x. And your c drops out. Okay, so they want us to find the cost of the first 220 dresses. So what are you going to do? Yeah, x is going to be equal to 220. Yes, you're going to plug it in. Where are you going to plug it in? The cost function or the marginal cost function? Yep, the cost function. So I'm going to figure out the cost of the first 220 dresses. So yes, negative 3/25 times 220 squared plus 60 times 220. All right, calculators out if they're not out by now, which I'm sure you probably do have them out by now. All right, my little cheat sheet tells me that I get $7,392 because it said round to the nearest cent. I rounded to the nearest dollar. Sorry. Cool? Okay. You round to the nearest cent. I rounded to the nearest dollar. Hopefully we at least agree to the nearest dollar. Got it? Love it. I got one more problem. And you're like, oh, it's the same. Kind of, but there's a little twist at the end. All right, last problem. Did you read it yet? Yeah, it's got a little twist at the end. So let's look at it again. We have a clothing company, once again a clothing company, determines the marginal cost in dollars per dress. So our marginal cost is given by a derivative, negative 4/25 x plus 51. And that has a restriction that x has to be less than or equal to 310. What does x represent? Yeah, the number of dresses. Got it. And it says the total cost of producing the first 160 dresses is given by $6,112. And they want us to find the cost of producing the 161st through the 220th dress. Okay, so they want us to find the what? Cost. So if we're trying to find the cost, we have to take the antiderivative. So let's get started there, shall we? We'll get to everything else when we need to get to it. So we're taking the antiderivative of negative 4/25 x plus 51 with respect to x. Okay, do your work, pause the video, come back, see if we agree. Okay, got your answer? Cool. All right, so I get negative 4/25 times 1/2 x squared plus 51x plus c. So my cost function right now is looking like negative 2/25 x squared plus 51x plus c. Now, do we agree? Good. Did they tell me to disregard any fixed costs here? They did not. They did tell me that when we produce the first 160 dresses, the cost is $6,112, right? So the cost of 160 dresses is equal to the $6,112, isn't it? Which basically means C of 160 is equal to $6,112. Are we in agreement with that? Wonderful. So, that's right, plug it in because I got to find that constant C. Agreed? All right. So, we have $6,112 equals negative 2/25 times 160 squared plus 51 times 160 plus that C. Okay, so when you do the work on the right side and you square the 160 times the fraction plus the 51 times, what do you get? You're like, hey, wait. Yep, I got the same thing. You get 6,112 plus C on the right side, don't you? Which means C is equal to 0. So they disregarded fixed costs, didn't they? They just didn't tell me that. So I can't assume it. I can't assume costs are disregarded unless they tell me. But based upon what they gave me, that's what they did. So what's my actual cost function? Yep, C of x equals 2, negative 2/25x squared plus 51x. All right, so what do they want? They want the cost of producing the 161st dress to the 220th dress. Now be careful on how you're thinking about doing this, because some of you may say, well, let me take 220 minus 161 and find that cost. Okay, if you actually do that, you're going to find the cost of 60 dresses, right? But those 60 dresses aren't supposed to be the first 60 dresses. Those 60 dresses are supposed to be between 161 and 220. And here's the thing about business. The more you make, theoretically, the less each item is going to cost. So, theoretically, item 2 should cost less than 1. Item 10 should cost less than item 6 when you're making items. So item 161 should theoretically be less than item 153. Got it? So if you're planning on subtracting the 220 and the 161, don't, because that's actually going to give you the cost of the first 60 dresses, not the 60 dresses between 161 and 220. So some of you are like, well, then how do I do it? It's actually quite simple. You are going to subtract, yes, but you're going to take the cost at 220 dresses and subtract the cost of 160 dresses. That's what's going to give you the cost of the 60 dresses in between. Got it? Okay, so you have to plug in 220 into the cost function. So you go do that work. And when you do that work, hopefully we agree, I got $7,348. And I'm subtracting the cost of those 160 dresses, which they already gave me as $6,112. And so I ended up with the cost of those 60 dresses between 161 and 220 is $1,236. Cool? Okay. You have to be careful because, as I mentioned, the more you make, the less each item should cost, because you just got the process running and running and running. It should cost less and less and less. Good? All right. Hopefully this stuff makes sense. You have fun with it, and I'll catch you on the flip side.